Hey guys, so if you're watching this video, it's because we're at home virtual learning, which sucks. But in this lesson, I'm going to teach you guys how to complete the square again because it's been a while since we've done this. So just to review, you can solve a quadratic, and remember, solve means we're finding the x-intercepts. Okay, so you can solve a quadratic or find the x-intercepts by factoring, by graphing, which we've already done as well, by using the square root method if it's in vertex form or if the middle term, the b term, is missing. And then if none of those work, then you want to complete the square, okay? Completing the square is a lot of steps. If you look at your guided notes from, like 2 Fridays ago, it is a lot of steps. It is a decent amount of work, but it is the next best way to solve a quadratic when we can't factor or when graphing is going to take too long, all of those things. So we're finding the x-intercepts by completing the square. Just to review, if you are given a quadratic like, I don't know, let's do 5x squared, this one should work, plus 20x minus 60. The first thing you want to try to do to find the x-intercepts, the fastest thing to do, we talked about this, is to factor. So if I take out my GCF of 5, then I'm left with x squared plus 4x minus 12 on the inside, and that does factor. So factors of 12 that subtract to give me 4 are 6 and 2. So remember, I'm just factoring, and if we want the 4 to be positive and we're subtracting, the signs are different. So that's a positive 6 and a negative 2. So my x-intercepts here would be negative 6, 0, and 2, 0, because I changed the sign when I take the factors out. If they give you a quadratic, the first thing you always want to try to do is factor, but factoring does not always work. I am going to start with the example we did like 2 weeks ago, just so you guys can watch this and review what we did on your guided notes. All right, so if I give you this quadratic, obviously the first thing you would want to do is try to factor. So I am going to show that to y'all, but it does not work. So if we subtract this 6 over to the same side, because everything has to be on the same side to factor, then this is 2x squared minus 4x minus 1. And no matter what factors you choose for this, if you do 2x and x and then factors of the back term 1 and 1, 2 and 2x plus 1x are always going to make 3x in the middle. So this one will not factor. Okay. So once we get here, there's nothing left on this other side. The next thing you want to do, sorry, I've got my emails turned on. The next thing you want to do is try to complete the square, because we are not missing the b term. So this isn't in vertex form, and we're not missing the b, which means the next best method to find the x-intercepts would be to complete the square. So from here, your first step is to make sure it's in standard form, which it is, and then it says from there, move the constant to the other side. So the constant is my minus 1. I'm going to add it to move it to the other side. So now I'm left with 2x squared minus 4x equals 1. Okay, so your next step, make the coefficient of the quadratic term, so the a value, equal to 1 by factoring if necessary. So my a value is not 1, it's a 2. So what this step is telling us to do is to take out the a, which means I'd be left with just a 2x for the next part. And that's only on the left side. So the constant that's on the other side, we're just going to leave the same. All right. So now if you look in front of your x squared, there is an understood 1. So we're good here. Okay. So for step 3, find the c value needed to complete the perfect square trinomial. So what we want to do is turn this x squared minus 2x into a perfect square trinomial. All right. So what that means is, what value for this back number would I need to make this a perfect square trinomial? This is, sorry y'all, I don't know what happened. My computer's acting up. So again, we want to try to make this a perfect square trinomial so we can write it as something squared. Okay. So to get negative 2x in the middle, that means that we had x minus 1 and x minus 1, right? Because negative 1 plus negative 1 is going to give us a negative 2x in the middle, okay? So if we have negative 1 plus negative 1 to get negative 2 in the middle, remember the back number is just negative 1 times negative 1, or negative 1 squared, which is 1, okay? So now we have made this a perfect square trinomial. The front term is a perfect square, x times x gives you x squared, and the back term is also a perfect square, 1 times 1 gives you 1, okay? So then my next step, step 4, we want to add the answer from step 3 to the other side of the equation. So what we added to the left was a 1, and we want to add that same thing to the right hand side. And I'm actually going to move this over so I leave room for our next example. Okay, now this part gives you a hint. It says make sure that if you factored out a number, you distribute it back in to add the entire product to the other side. So on the inside for the perfect square trinomial, we just added 1, but there's a 2 sitting out front. So really we added 2 times 1, which is 2. Okay, so that's step 4. So step 5 says factor the perfect square trinomial and simplify the other side. So on this side, we want to factor x squared minus 2x plus 1. Remember, we just made it a perfect square trinomial. So that means the first and last term are perfect squares. So the square root of x squared is x. The square root of 1 is 1. We want it to be negative, so this is going to be a negative 1. And that's how you factor a perfect square trinomial. We have done that in person before. If you need help with it, please feel free to video chat me or Google Voice me. 1 plus 2 is 3. And then once you get here, this looks like vertex form. So since it's in vertex form now, we factored the perfect square trinomial, then we should be able to solve the new quadratic equation using the square root method. So remember, let's review. The square root method says that if I cover my squared term and move everything else to the other side, then the opposite of squaring something is to take the square root, and we should be able to solve for the x-intercepts. So if I divide this 2, because it's not being squared, what you do to one side you do to the other, then this is x minus 1 all squared. Okay, from here the opposite of squaring something, because all of this is squared so it's by itself, is to take the square root. And so now we have x minus 1 because the squared and the square root just cancel out. So these two things cancel. Equals, and remember when you take the square root, you can have the positive root or the negative. So we're going to have plus or minus square root of 3/2. Now we can't simplify this because we can't take the square root of 3 and we can't take the square root of 2. Those are irrational numbers. So I'm okay if you guys just leave it like this. And our last step to get x by itself is to add 1 to both sides. So this is going to be x equals 1 plus or minus the square root of 3/2, which means my first x-intercept is 1 plus the square root of 3/2, and my second x-intercept is 1 minus the square root of 3/2. Okay, so that's the first example we did in class on Friday. So now I'm going to do another example with you guys, and I'll probably do a third one too, just depends on if I have enough time.